Welcome to this podcast on architectural acoustics and specifically about simulation acoustics with Pachyderm Acoustics by Rhinoceros. In this podcast, we will focus on how to map a simulation onto a region or a surface rather than looking at singular positions in space. So here we have the Utzon Center Auditorium. We have the fortunate to do lectures often and to meet the students and so forth. But what we're interested here is, of course, to use this as a framework for making simulations and mapping of this sound. So in the model, we have now the specification of the geometry and the materials. We have a source, and we have a set of microphone receivers in the space. These we have already covered in an earlier podcast. So rather than, as mentioned, looking to specific points in space, we will look to a surface, which in this case is the whole region here and the whole area where the audience is sitting during a lecture or during other events in the auditorium. So what we'll do here is we can see we have already the seats in here. But following the industry standard, we will, instead of having seats, we will have an area which includes the seatings and the potential occupancy of the listeners in the space. And in this case, this is constructed by a surface in the top, which we will use to map the results onto from our simulation, and a volume that is defining the properties for this zone in terms of occupancy. So if we open up the Pachyderm acoustic interface again here, we will see that the simulation plane of the surface of the occupancy here has applied a high level of absorption due to the absorption properties that are for an occupied auditorium. Right, so what we'll need here is that we will go into the Pachyderm mapping method. I already have it open here, but it's found here. Now I'll turn it off and turn it back on. There we have different tabs here: calculation and output and impulse on a T-flip tab. And the first thing we're prompted with is to find the surface that we want to map the data onto, map the simulation result onto. So what we basically do is we press the button, it's select mapping surface, and we choose the surface which is in the top here of the space. And press enter. We have the surface now included in the Pachyderm simulation interface here. And then we have some possibilities to change the definition of this surface in terms of how the audience is placed and where if to understand the position of the simulation point on this surface. And typically we are looking at in the face centroid. So when we subdivide it in a minute, we are interested in positioning the point of listening or the point of simulation in the center of that phase. Also, what we need to look to is the number of rays. In this particular case, in terms of its size, a reasonable amount of rays would be between 50,000 and 100,000 rays. But in this case, we will just make it lower in order to have something that not takes so long. But in reality, this number should be much higher. In fact, I will change it to 10,000 for this. Cutoff time, how long will it run, and then the increment in centimeters of the map. The distance between the simulation points on the surface. And the moment it's positioned to, or it's in the increment or the resolution of the map is 50 centimeters. This you can of course change as you prefer. Let's make it just 25 now. Yeah, this has basically to do with the positions of the people in the space. Then you have the environmental factors as shown with the simulation earlier: air temperature, relative humidity, and the pressure, and the method for simulating the acoustic properties. And then we're basically ready to run the calculation, and this will take a little bit of time, so I will start it, and then most likely, depending on how fast it will go, I will cut forward to not having you to wait so long for the simulation to finish. So now we have calculation has been completed. Have a nice day. So this means, of course, we have a successful simulation. At the moment, we only have the calculation and not the output. So we go to the output tab, we mark the source, and we then have different options here of configuring the visualization of the sound spreading in this on this surface. So basically, what kind of force color plot are you interested in? What are the parameters that you're looking at, sound pressure level, vibration time, and so forth? Are you looking at specific bands, octave bands, or are you looking at summation? And so forth. What should also be noted here, of course, is that the interval is now running from 90 to 0. So the colors will be interpolated between these two values. But when we look at the source properties, we can see that the sound pressure, the source is much lower here, which means we will not have a correct, or it is not a very feasible way to distribute the colors in relationship to the source. So here we will much more look perhaps at a range between 60 and 50 to start off with. And then create a map. So it appears like there's nothing here, but we need, that's because in wireframe we need shaded view, and then now we have a mix between the surface from before that we mapped it onto and the new mesh that is created based upon the simulation. So every time we create a map, we basically plot a new mesh with information and the force colors that are applied from the interpolation here onto that surface. So every time you press a create map, you will get a new mesh here. So here now we can start to see a spreading of the sound across the surface based upon the settings and the properties of the space. And you will have to tweak, obviously, to get the best match between the representation of the surface and in relation to the properties of the acoustics of the space. So this is a way to map the acoustic properties in space rather than putting or trying to analyze only in points of the space. Other things that can be mentioned here is that you can go to auralization and you can output this towards an auralization procedure, or we can here see what is a T-flip tab is that we can start to animate how this sound is spreading on the surface. So if you just leave the default settings as they are, same time intervals and step increment and so forth, we can start to get an understanding of how the sound, in this case, decays with the sound pressure level across the surface, or any other of the variables that you have chosen to look at as a means of understanding the acoustics of the space. So this is a very powerful way, in a sense, to start to understand the space and the spreading of sound across surfaces rather than on points. And it includes a specified method for calculating this, for visualizing it statically, but also elegantly showing the spreading in a dynamic form through the T-flip method, as seen here. That's it for mapping acoustics in Pachyderm for now. Thank you for watching this podcast.